Welcome, this is Mr. Anderson. We're first going to take a look and review simplifying a radical expression. And then we'll take a look at adding and subtracting algebraic radical expressions. So here we have square root of 72 a to the 8th b to the 5, and I'm looking for pairs and perfect squares. This 72, and I know 2 times 36 is 72. And I wrote that down because I know the square root of 36 because it's a perfect square. I know the square root of 36 is 6. And then I have a to the 8, b to the 5. And I'll write it a little weird here. I'll write a to the 4 times a to the 4, like that. And then b squared times b squared, and then I've got one more b in there. There's 5 b's multiplied together, right? B squared is b times b. There's another b times b and another times b, so I got 5 b's multiplied together. That would make b to the 5. Same thing here. I've got 4 a's multiplied together here, another 4 a's multiplied together here. I got a total of 8 a's multiplied together, and that's the same thing as a to the 8th. Now, I'm just going to go down the line, and if it's pair or perfect square, I can take it outside the square root. So 2, not a perfect square, and not paired up with anything, so it stays underneath the radical there. 36, I know the square root of 36 is 6. That's a perfect square. And I have a pair of a to the 4s. So I can take that outside the radical as a to the 4. I have also another pair of b squareds. I can take that outside the radical as b squared. And then I have this leftover b, which is not paired up, and it's not a perfect square, so that has to stay underneath the radical. And I'll end up with this, combining it all together at the end, I'll have 6 a to the 4 b squared times radical 2b. I also want to take a quick look at expanding all of this out and then only taking out pairs. Okay, so let's expand this all out. That's going to be kind of long here. Try that. Okay, so 72. What is 72? Rather than writing 2 times 36, let's just do a quick factor tree on this. 72, well, let's write it 9 times 8. And 9 is 3 times 3, 8 is 4 times 2, and then 4 is 2 times 2. So if I write 3 times 3 times 3, whoops, another 3. Back that up a little bit. Okay, times 2 times 2 times 2. That would equal 72. That's my prime factorization here. Notice 3 times 3, that's 9. 2 times 2 times 2, that's 8. 9 times 8 is 72. All right, so I broke that one down as far as I can. Now I got a to the 8th. The 8th power means that's how many times you multiply that base times itself. So I've got 8 of these a's all multiplied together. I got 1, 2, 3, 4, 5, 6, 7, 8, and then I got 5 b's. 1, 2, 3, 4, 5. So in this example here, I'm going to end up with the same answer, but here I'm just looking for pairs. I don't have any perfect squares here because I broke it all down as simple as I could get it. All right, so here's a pair of 3's. Take it outside the radical as one of those 3's. Here's a pair of 2's. Take it outside the radical as a 2. That 2 is all by itself. is not paired up, so that stays under the radical. Pair of A's. There's an A, another pair of A's. Take that outside the radical as one of those A's. Another pair of A's. Take it outside the radical as A. Another pair of A's. Take it outside the radical as A. Here I've got a pair of B's. Square root of B times B is B. Take that outside the radical as B. Another pair of B's. Take it outside the radical as B. And then I've got one left over, B. It has to stay under the radical as square root of B. Now combine it all together here. 3 times 2 is 6. And then I have 1, 2, 3, 4 A's multiplied together. That's A to the 4. And then B times B is B squared. And then I have square root of 2 and square root of B. Combine those together. I have 2 times B under the square root. Notice that. End up to this same simplification. It's just in the first one, I look for both pairs and perfect squares. All right, it's kind of sped things up a little bit by doing that. And in the second one, I just expanded the whole thing out as simple as I could get it. So what do we have? 6a to the 4. Try this. We've got 6a to the 4. Right? And there we go. And it was b squared, I think. And then underneath the radical, we still had a 2 and a b. Looks like they wrote it okay. And so, oh, not yet. That's question number 2. Question number 2. Okay, so here we go. We got square root of 2 and square root of 8 plus square root of 50. Now, here is the radical rule about adding and subtracting. All right, so let's say I have just a sidebar story over here. Let's say that I have 3 square roots of 2, and I'm adding to it 5 more square roots of 2. So like these square roots of 2, kind of like an x. If I had 3x plus 5 more x's, I would have 8 x's. Right here I have 3 of the square roots of 2 plus another 5 of the square roots of 2, and I'd have 8 of the square roots of 2. Right now, if I had 3 of the square roots of 2 plus 5 of the square roots of 3, I cannot combine these. Right? I cannot combine these. I can't call it 8 square roots of 5 or 8 square roots of 6, something like that. It's kind of like the same thing as saying I've got 3 of the x's plus 5 of the y's. I cannot combine those, right? So let's take a look back over here. I've got 1 square root of 2 plus 1 square root of 8 plus 1 square root of 50. And so you're like, okay, well, none of these match up. I can't combine those. That's like x plus y plus z, right? But not so fast, because we can simplify this. We can simplify. You always want to simplify those radicals first and then see if you can add them. So square root of 2 doesn't get any simpler than that. We'll leave that as square root of 2. Now, square root of 8. Right? Square root of 8, that's 4 times, square root of 4 times 2. Right? Square root of 8. We know the square root of 4 is 2. And then we have that square root of 2 left under the radical. Right? So square root of 8 is the same thing as 2 square roots of 2. And then square root of 50. Right? So we got square root of 50 equals square root of 2 times 25. Or 2 times 25. Well, I do know the square root of 25 is 5, and I can't do anything with that remaining square root of 2. So the square root of 50 is 5 square roots of 2. Now take a look at this. Now I have one of the square roots of 2 plus 2 more of the square roots of 2 plus 5 more of the square roots of 2. I have here all square roots of 2. I can add these. This would be like saying I got one of the x's plus 2 more of the x's plus 5 more of the x's. All right, so you have to simplify these radicals first to see if you can add them or not. So what do I have? I've got one of the square roots of 2 plus another 2. Now I'm up to 3 square roots of 2. And then I add 5 more square roots of 2. So I end up with 8 square roots of 2. All right, I'll write that in our answer here. 8 square roots of 2. That's our final simplification. Okay, next question. Okay, same thing here. I've got square roots of 12 minus 2 square roots of 3 plus square root of 108. So square root of 12, that can be broken down to 4 times 3. And I'm going to leave this. Then we got minus 2 square roots of 3. I've got 108. So let's think here. 108, I can multiply that 9 times 12. Right, 9 times 12 would be 8. Let's just break down 108 and think about it a little bit here. I could say 9 times 12. That's 108. It'd be 90 plus 18. And that's 3 times 3, but I already know that's a perfect square, so I'm not going to mess with that one at all. And then 12 again, that's 4 times 3. All right, so I'm going to add this 108, and I'm going to write it 9 times 4 times 3, right? That's 9 times 12. That gets me 108. So let's see what we have here. 4, the square root of 4 is 2. And then I have square roots of 3. Subtract off of that 2 square roots of 3. And then add to that, let's see, we know the square root of 9 is 3. The square root of 4 is 2. And then I can't do anything with that square root of 3 that's left over. It's not a pair, and it's not a perfect square. So I have 2 square roots of 3 minus 2 square roots of 3. Okay, that gives me 0 square roots of 3 plus 3 times 2 square roots of 3. So 6 square roots of 3. And there's my final answer. 6 square roots of 3. Bother writing that into the thing there. Let's take a look at another one. Okay. Question 4, question 5. I'll take a look at one with a variable. Okay, here we go. So we have 28x minus 14 plus 63. 28x minus 14 plus 63. Well, we need to simplify all these radicals. So 28x, that would be 7 times 4x. Right? 7 times 4 times x. Because I know the square root of 4 is 2. Then we subtract from that square root of 14. Well, let's see. I break down square root of 14. I can get 7 times 2. I don't have any pairs or perfect squares there. That doesn't help me out any. And then I got plus 63. That'd be 9 times 7. Okay. And then I have that x in there. Let's see how this simplifies down a little bit. 4, that is, square root of 4 is 2, and then I can't simplify the other two things, right? This 7 is not a perfect square, not a pair. X is not a perfect square, it'd have to be x squared, and it's not paired up with anything, so I have a 7x still under the radical. And then this, nothing can be simplified in the middle term there, so that's still square roots of 14, 1 square root of 14. And then I'm adding to that, well, the square root of 9 is 3. And then I can't do anything with the 7x, so that stays under the radical. So my final answer here, I have 2 square roots of 7, and I can combine that with this over here. I can combine this 2 square roots of 7 with these 3 square roots of 7. So 2 square roots of 7 plus 3 square roots of 7 is going to get me 5 square roots of, well, 7x. 5 square roots of 7x. And then I can't combine this one with anything, right? Because these are square roots of 14. They're not square roots of 7x. So my final answer then is 5 square roots of 7x minus one of these square roots of 14. That's it. That's as far as I can simplify it. Okay, one more. Let's take a look at one more. Let's see. I got 135. Now, 135, 10, and 60. I'm already starting to think, hey, those can all be divisible by 5. Maybe each one of these is going to be a square root of 5. But then I have a d in this one, and I don't have d's in the other, so I know that I'm going to end up with 2 terms here no matter what. Well, let's see what we end up with here. 135. Let's break that one down. 135. That would be what? 3 times 45. 90. Well, yeah, 3 times 45. There's your 120 plus 15. And then this breaks down to, I got 3 times 9 times 5. And I'll leave it at that. The 3 and the 5 can't be broken down anymore. But I see that 9 is a perfect square, so I'll leave that alone right there. And then this middle one, I have 5 square roots of 2 times 5d. All right, that doesn't help me out any, because 2 and 5, those aren't pairs or perfect squares, so I'm just going to end up with 10d here still. And then I'm subtracting off 3. Let's see, how can I split up this 60? How do I split up this 60? I could take, let's just look for pairs on this one. Let's take 6 times 10, and that would be 3 times 2 and 2 times 5. Okay. All right, so I've got 3 times 2 times 2 times 5. Okay, let's see how that worked out here. Simplify this first radical here. I know the square root of 9 is 3. And then the rest of it cannot be, it doesn't have a pair or a perfect square. So 3 square roots of 15 here. And then I couldn't do anything with that middle term. I got 2 times 5d underneath the square root, and none of that is a perfect square or pair. So that's still, I got 5 of the square roots of 10, and I'm going to subtract off 3, and then I have 3, and I can take that 2 outside. So 3 times 2 of the square roots of 15. I still have a 3 and a 5 underneath the radical. So we've got 3 square roots of 15. And here's another square roots of 15 on the end. 3 times 2 square roots of 15. So 3 square roots of 15 minus 6 square roots of 15 is going to give me, 3 minus 6 is going to give me negative 3 square roots of 15. And then I can't combine that 10 square root 10d at all. So I got plus 5 of the square roots of 10d. There's my final answer there. Okay. I think that's pretty good for looking at the adding and subtracting. One thing that I really want to impress upon you is that, hey, you got a square root of 3 plus a square root of 2, right? You cannot add those. You cannot call that the square root of 3 plus 2 is the square root of 5. No, you cannot do that. That is bad. That's bad math. All right, you have to have the same radicand. Okay, you got to have the same number underneath that radical. And these radicals, by the way, they both have to have the same index, right? This is a square root, so the index is 2, right? I couldn't do this either. I couldn't say the square root of 3 plus the cubed root of 3, right? That's no good either, because this is square roots of 3 and this is cubed roots of 3. Those do not match up either. All right, so I'm not gonna add those. I have to have the same index there. And however, let's say I had 10 of the square roots of 2x, and I was adding to that 3 more of the square roots of 2x. Now this I can add. Or let's say it was 10 of the cubed roots of 2x plus 3 of the cubed roots of 2x. Right? That I can add. That's good. That would be 13 of the cubed roots of 2x. Okay? All right, that'll do it. I will see you later.